This one looks different because I have a lot of variables in it. I have f of t equals the square root of t times a plus b to the t power. With this, if you see something in function notation like that, t is my variable. So these are my variables. A and b are just representing constants. So if I were doing the derivative of this, okay, my product rule, derivative of the first, a square root of t is like t to what power? So I have t to the 1/2 times my a plus b to the t. Again, you could certainly multiply this out, but we're practicing product rule, so I'm not going to yet. So derivative of the first, derivative of t to the 1/2 would be times the second, so my a plus b to the t stays, plus the first, t to the 1/2, times derivative of the second. Okay, in this, t is the variable. A is a constant. What's the derivative of a constant? 0. So the a goes away, plus b times, what's the derivative of t? 1. So I just get b when I do that. Because a is constant, so its derivative is 0, plus b times, when I do my derivative of t to 0 is 1, so that's what my b. Right. So then if I want to clean this up, if I distribute 1/2 times a, so a over 2 to the negative 1/2, plus b over 2. If you add exponents, 1 plus 1/2, negative 1/2 is 1/2. Plus b to the 1/2. These two are like terms. B over 2 plus b, so 1b over 2 plus 2b over 2. Okay, so if you have multiple variables in there, only one of them can be acting as a variable at a time right now. Any others would have to be constants. And you know which one is the variable by your function notation. So if I said f of a would be the variable, b and t would be acting as constants there. All right. Any questions on that one? Let's try this. If f of x is the square root of x, so that's like x to the 1/2, times g of x. Okay, g of x is representing another function. Did I tell you what that function was? No, so it's forcing us to do the product rule here. I want to find f prime of 4. So first, let's do our derivative. We do one derivative at a time. So derivative of x to the 1/2, 1/2 x to the negative 1/2. Second one stays the same. Plus the first times derivative of the second. Derivative of g of x would be I want my derivative at 4. So I have to plug in 4s for all my x's. Okay, 4 to the negative 1/2. So a negative, we'll put it on the bottom. 4 to the 1/2 means the square root of 4, so that is 2. So 4 to the negative 1/2 turns into 2. Times, what did I tell you g of 4 was equal to?
2.
Okay, 4 to the 1/2 means the square root of 4, so that's 2, times g prime of 4, and I told you that was we get 1/2 plus 6. So 6 would be like 12 over 2 plus 1 over 2, so 13 halves, or 6.5, or 6.5. One thing, if I am ever asking you to evaluate the derivative at a certain number, you have to do the derivative before you plug the number in. The reason is, if I put a 4 into the beginning, even if I had a simple function, my function were like x squared. If I put in a 4 to start with, that's equal to 16. What's the derivative of 16? 0. If you plug in your number first, you get a constant, and the derivative is always 0. So you have to do the derivative first, get that equation, and then plug in your number. So never plug in the numbers until the end. Well, let's go to this one. Find z prime of t, or dz dt, if z is equal to this. So, I have a quotient. That means quotient rule. So, that's low. D high, what is the derivative of the top? Minus high. D low, what is the derivative of the bottom? So if I distribute, we get 3t squared. The 6. On this one I distribute the negative and 4t cubed. So minus 4t cubed plus 4t to the 6. You can choose to FOIL out the bottom. I am not going to. So combining like terms. Negative 3t to the 6 and 4t to the 6 is t to the 6. That's my 4t cubed minus my 3t squared. Over 1 plus t to the 4th. I want the equation of the tangent. To find the equation of a line, we need a point and a slope. I gave you the point. How do I find the slope of the tangent line? Find her derivative. This is a fraction. E to the x over 1 plus x squared. So, low. D high. What is the derivative of the top? The derivative of e to the x. Minus high. D low. What is the derivative of 1 plus x squared?
2.
Over low squared. So 1 plus x squared squared. If you multiply off the top, you get e to the x plus x squared e to the x minus 2x e to the x and 1 plus x squared squared. All right, there's really nothing we can do to clean that up, but remember, we're just trying to find our slope. To find our slope, what do we have to do?
Entering your point, your one, your x value.
Our x is 1, so if I plug that in, e to the first is just e, plus 1 times e is e, minus 2 times 1 times e is 2e, over 1 plus 1 is 2, squared is 4. What do we get? 0. If it's 2e minus 2e is 0 divided by 4. So now my slope is 0. So if you think y equals mx plus b, our y was 1/2 e, slope is 0, x is 1 plus b. Our y-intercept is 1/2 e. So our equation, since our slope is 0, that term drops out, so it's just y equals 1/2 e. We have a horizontal line. Since the slope is 0, it's just y equals 0. What questions do you guys have? The last slide on here is just a summary of everything we found so far. The derivative of a constant is 0. If you have x to the power comes down, subtract 1. Derivative of e to the x is still e to the x. If you have a constant times something, you just keep the constant and do the derivative. If things are added, you do individual derivatives. If they're subtracted, you do individual derivatives, and then our product and quotient rule. So that's everything we've learned about derivatives so far. There is more, but this is everything we have to this point. So I want you guys to try some book problems. We have a lot of time right now, so let's work and see what questions come up.